This is the part we are gonna make. It's a drawing of the part. Some of you may recognize it. It's quite similar to one Chandima use. Only thing I have done is made the measurements in millimeters. Uh, yeah, it's a square with a hex on top with 4 holes. So this is a picture of the stock we are going to use, how the part will look after we have done first operation milling, and also one finished product. So first we start from the top, we mill uh, as low as we can go, and then we take a little bit from the backside if we want to finish the whole part. This tutorial will not show how to program the backside, but that's only some facing, and you will see facing first in this tutorial. So first we start to choose a Mazatrol program. We can also program in G codes, but we want to program Mazatrol. We choose materials, carbon steel. Here we select the clearance for 10 millimeters, how many axes we want the machine to move inside the clearance, and we only want to make one part. The first thing we gotta do is set the 0 point. When we program it, we just put example -400, -400, 0, -400, minus and 0. So this is the X, Y, and Z axis. The other one, it's if we want to make it not flat, so we don't need to think about this now. We start with a facing operation. How deep do you want to go? We want to go 1 millimeter down. How much do we want to leave for the finishing? We choose which tool we want to use. We want to use the face crown, and set the machine to tell where is the best place to start this operation. Here we set the depth, feeds, and speed, and also M8 for having coolant. We choose the same tool for the finishing. We want it to do the same direction, and we also need coolant here. We want to do a square, so now we will face the whole top part. We start in a corner and finishing in corner 3. So the stock is 120 times 120, so we will start in 0, 0 and finished in 120, 120. Now we want to do milling on the sides. We want to use an end mill, and here we will check the drawing, how deep we want to go. We want to go lower than the bottom part because it's a radius on the tool. So here we go 31 deep, and we would need to go at least 29.8 because of the radius. Here we choose an end mill. For the rough, we choose a 20 millimeter. This have some tools we can, the tips we can change, and that make it just more cheap to use it. Here we change the depth. I know this mill can take a maximum of 10 millimeters, and this is how wide we wanted to use it. I just put 1 millimeter because then we can mill faster. So I take small cuts that is going fast. And also we want the M8. We use coolant almost all the time. In this part we'll use it all the time. For the finishing we choose a different mill. We choose an M12 mill. Here we can just leave the width of the work at 8 millimeters because we have told the machine that we will leave 0.25 millimeters here. So we start programming the square. It's we start from 0, 0, 120, 120, and then we need to program where it will end, because now we need to program the inner square that will end 5 millimeters in from both sides. But the y-axis we need to change to 10 millimeters because it's 110 wide and long in the x direction and 100 in the y direction. So to have it in the middle, we program it 5 in the x and 10 in the y, 115 in the x and 110 in the y to end. Also, I put a small radius on. That's just to not have the sharp edges. It just feels better when it's done. Now we're gonna program the hexagon. This is only 10 deep, and we want to machine all 10 of those. Here we say the machine also to leave 0.2 millimeters for finishing. We use the same tooling, the 20 mil and the 12 mil. The machine will calculate where to start. And the depth we set to 10, wide 1 millimeter, 200 millimeters in speed, and 0.7 feet. So where you can see the medur, this is which way you want the mill to rotate. It's clockwise and counterclockwise. First we program the square we got. It's the same square as we made on the last line. And then we choose not the square, not a circle, but we choose the different one, and we need to program each line on the hexagon by itself. So then I just plot the coordinates for all corners. I have been getting those coordinates from the 3D model. And also I put on a small radius on each corner of 0.05, just to not have the sharp edges. So if you want to follow the 36.91 X and 20 in the Y, it's the bottom left corner of the hexagon. And then I just program each line from there to the right and go around the hexagon. So now it's the end line. I don't need to program it to go back to start. The machine knows that it will do that. So I just choose shape end. Now we need to do the hole. Then we choose the point machining. We choose drilling, which diameter we want of the hole. And I know that in the tool library of the machine, it's a drill that is 11 millimeter. So this is if I want a chamfer. So I don't want a chamfer on this one, so I just put in a zero chamfer. I will delete the center drilling because I don't need to drill a mark for this drill. So this is the depth. I choose 34 because then I know you will have at least 29 full drill, and we don't need to drill from the opposite side when we have done the drilling. So what I just chose was to have chip breaking. And there the video stopped. So this is the same program. Now I will just, because I know that the 12 millimeter end drill can take the whole 31 depth. So then I want to delay the tool to come to do all the roughing first and then do the finishing with the 12 mil. So then I put in a number, is a delay number, and I only put the delay number on the finishing end mills. And when I put it only on those, they will come in the end of the program, even though it's programmed in the middle of the program. And also here we can see the rest of the programming. I have chosen the depth of 2 millimeters for the drill. The speed is 30 because it's a high-speed steel. The other one is carbide, so it's quite different. There, on this one we got 200, here we got 30. And the feed is 0.07 and also a coolant. I choose to program it from a circular pattern. We want the circular pattern to start in the 0 of the set. It knows the 0 is the top of the model after facing. And I program where the center of the circle is. It's in the middle of the part. So 60 from the X and 60 from the Y. I want to start the hole in a 45-degree angle. And I want the radius of the circle that the hole will be programmed with is 25. And I want 4 holes. So when I have gotten those inputs to the machine, it knows where the hole will be placed, and it will place them in a circular pattern of a radius 25. I could also program this, since it's 4 holes, I could program it in a square pattern and have 1 in each corner. But on the drawing it was done with a circular pattern, so that's just easier. And then I also program, this is the end of the program. I tell the machine that I don't want this to go continuously. If we choose continuously, it's like a production environment. If we got a robotic arm that can place the stock in the machine and fix it, then we can have continuously. Also, I got the option to have the machine count how many parts I made. That's normally used if you got several items you want to make, and if you don't stay with the machine all the time, then it can be easier to just have a quick look and see how many parts have you done now. We also got the possibility to tell them after this program, move forward to program a different program and continues with that program. For example, if we got a robotic arm, then we can choose a different program and tell this program to turn the part and program the facing in that program, and then send it back to this program when it's finished with the other program. So this is, as I say, just a delay. We got the possibility to simulate the result in the machine. Here you can see what we have programmed. And here is a simulation of where the tool is moving. So here you can see at all time the coordinates of the tool. And here we can see how long it will, how much time we have used on each part, and also how long in the simulation you find, for example, this mistake you are looking for. So I can delete the simulation whenever I want and continue. I also got the possibility to, if it's something looking odd, it's easier for me to see than for you. I can push it to go one step at a time. I also got the possibility to see it from what angle I want. So I can see if the drill is going deep enough, the end mill is going deep enough, and things like that. And also there are points here, you can see the time. So it will take 25 minutes and 39 seconds approximately.